In this short video, we're going to learn how to do some data analysis in CODAP. We're going to take kind of a data science perspective as opposed to a statistical perspective. Here we have a typical CODAP window. There's a graph, which is all mixed up and completely random, and a table that has our data in it. This table has one row for each person in a set of 800 people. So we have data about these people, their age, weight, height, BMI, etc. And the thing about these people is that they're age 5 through 19, that is, they're children and teenagers. You can make the table bigger by stretching it, but we don't really need to do that, or you can scroll through it using this scrubber here. But really, you can see that, for example, this is an 18-year-old male whose height is 176 centimeters. Now, suppose we were going to investigate height. First thing I might do is make a graph of height. And this graph is all mixed up. How do I make it a graph of height? Well, you see it says click here or drag an attribute here. So what we're going to do is we're going to take this attribute height, the variable height, and drag it to this axis. And so I just go to the column heading and I put my mouse down and I drag, and I don't drop it here. I'm going to put it over here on the y-axis, on the vertical axis, and here now we have a picture of the distribution of heights, one dot for each of the 800 people. If I click on a dot, the table will scroll to the person, and so this is an 18-year-old female who's 160.7, or if I click on the row in the table, in this case, I have this 5-year-old male, 117. Well, there he is. He's highlighted. Okay, so suppose we wanted to look at the sex difference in height. The way I would do this in the graph is to take sex and drag it to the other axis. So if I drop it here, look what happens. It creates two parallel distributions of the males and the females and their height. It looks like the males are taller than the females in general. And in fact, if I go here to this menu with the ruler, this is the measure menu, I can put the mean on the graph. And when I do that, I see that the males are at 159.5. See, when I hover over the line, I see the value. The mean of the females is 149.6. The males are about 10.5 centimeters taller on average than the females. Problem is, this is not really a fair comparison. Think about that for a moment, and I'll come right back. Here's why I don't think it's fair. We've lost track of the age in this graph. In fact, age has a great impact on height. We know that the older children are, the taller they are. And so in some ways, it's a little unfair or bogus to just look at sex instead of age as well. So let's see what happens if we put age on the horizontal axis. If I do that, oh, now this actually makes some kind of sense. That is, as people get older, they get taller. Then it kind of levels out here after about age 15. But you can see that even though the ages are the heights are spread out at each age, as you get older, in general, the children get taller. So this makes perfect sense. But now we've lost sex. What do we do about that? Okay, so I can drag sex in again, but instead of replacing it, I'm going to drop it in the middle. And that creates a legend. We're going to color the points by the values of sex. So all of the males are now kind of orange colored and the females are purple colored. And I can see that in general, the top points up here are orange and the bottom ones are purple, and they're somewhat more mixed up here among the younger kids. But it's a real problem because, look, all of the points are smashed on top of each other. Because the ages are exact integers, like 14, you see that all the 14-year-olds are kind of piled up, and I can't really tell what the distributions are like. Here's a solution to that problem. let's look just at the 14-year-olds, just temporarily. We'll just look at the 14-year-olds and see what's up. So I'm going to select the 14-year-olds, and how to do that is I'm going to start above and to the left of these points I want to select. I'm going to draw a rectangle. So I'm going to make a tall, skinny rectangle. I put the mouse down here, and I drag, and you can see that I've selected them all. You can see the gray rectangle. Now all the 14-year-olds are selected, including, incidentally, this male here. In fact, all of the 14-year-olds in the table are also selected. This is something CODAP does for you, is when something is selected, it's selected everywhere. Now I want to look just at 14-year-olds, so I'm going to go to the eyeball menu, which is all about showing and hiding things. And so I'm going to hide the unselected cases. So I click there, and now I see only 14-year-olds. This graph is still not useful because things are piled on top of each other, but I no longer need age because they're all 14. So I'm going to put sex back on this axis, and now we see something that makes perfect sense. You can see that the males are taller than the females. These are the two distributions, but everybody's the same age, so it's a fair comparison. And when I put the mean on, I can see that once again, the males are about 10 centimeters, 10.5 centimeters taller than the females. So that's kind of what we expect, but this is only the 14-year-olds. I'd really love to do this for each age separately. Well, I could go back and get all of the cases by doing show all cases. And so once again, I have them all, and I could choose just, it's going to be really complicated. I'll have to put age back. I'm going to select only the 5-year-olds. I'm going to record you can see what's going to have to happen. It's going to be a mess. But suppose we had the computer do it. How can we have the computer help us? Well, what we'd like to do first is group all of these people by age. And in order to group these cases by some value, I take this age and I drag it, but instead of dragging all the way to the graph, I'm only going to drag it to the left in the table until I get to this margin here where it says drop attribute to create a new collection. So when I do this, I've made a separate group for every age. And so, for example, if I select the 5-year-olds, they're all selected and they're all together in the table. Really, it's as if there were 15 different tables piled on top of each other here. Now, some people can get a little upset that these ages are not in numerical order. Let's fix that. It doesn't matter that they're not in numerical order, but you might feel better if they were. So I'm going to click on age and a menu appears. I can edit attribute properties, edit a formula if I want. We're going to do that in a second, but I can also sort them. So I'm going to sort them, and now all the 5-year-olds are up at the top of the table, followed by the 6-year-olds, followed by the 7-year-olds, and so forth. At this point now, I would love to find the mean height of these 5-year-olds. And I don't want to do it over here where I have to use this line and hover. So I'm going to make a new column. And I want to make the new column over here because I want the value for each age. Now there's a plus sign here, so I'm going to click that to make a new column. And I'm going to call this mean height. So it's called mean height, but there's nothing here. Oh, I have to give it a formula. So I go to the menu again, and I'm going to choose Edit Formula. This is a new box we haven't seen before. And I'm just going to type mean, open parenthesis, height, close parenthesis, and click Apply. And now each one of these cells holds the mean height for all the people of that particular age. So for these 5-year-olds, their mean height is 113. For these 11-year-olds, their mean height is 152.28, and you can see them selected here. Interestingly, I can now actually make a graph of just these data. So let me make a second graph. Ooh, this is actually kind of nice to make two graphs at once. I'm going to put age on the horizontal axis. I'm going to put mean height on the vertical axis. And now you can see the overall pattern that we almost saw over here. I'm going to put age on the horizontal axis again. How they got older and then it sort of leveled out. Look, sorry, got taller and sort of leveled out. Here, again, they get taller and they sort of level out. In this graph, you see all of the data, including the spread at each age. Here you don't see the spread, but it's a very clean graph that communicates clearly about the mean height of each age, how it goes up to 15 and then sort of levels off. The problem here is that we've lost sex. What I'd really like to do is, instead of just grouping by age, I want to group by age and sex. Instead of 15 cases for the ages 5 through 19, I want 30 cases. I want the 5-year-old boys and girls, the 6-year-old boys and girls, and so forth. To do that, I'm going to take sex and drag it to the left, and I'll just drop it right by age. So now there are 2 5-year-old cases, female and male, 2 6-year-old cases, female and male, and so forth. And each mean height is the mean of that particular group. Now in this graph, I can't tell which sex is which, but there we go. I can drag sex to the middle of the graph and create a legend like we did before. So now the purples are the females and the oranges are the males, just like up here. And you can see what happens. From age 5 all the way to age 12, the boys and the girls are about the same height, though the girls are a little bit taller at 10, 11, and 12. And then the girls stop growing so much, but the boys keep growing fast for 2 more years, 2.5 more years, and then they level out. So that after about age 15, the boys are 10 centimeters taller than the girls. And it's only because they grew for 2 years while the girls were not. This graph shows the real story of what's happening in height data. And it's much easier to understand than this graph that shows all of the data. So, how did we do this? What are the data science moves that we made? First of all, we selected a subset of the data and investigated it separately in order to get an idea of what we wanted. We discovered we wanted the means of the boys and the girls. Then we grouped the data and we used the table in order to group them, all of the data, into groups with common age and sex. So we have 30 groups. Finally, we actually computed the mean height for each group. That required a formula and making a new column. Okay, we hope that that shows you what you need to see and that you have enjoyed this video. Thanks.